Okay. All right. Welcome to our check-in before the third exam, and we'll talk a little bit about what you've been studying for the last several chapters. The next uh, and we'll just point out where remind everybody where the resources, the extra resources for studying are located on our Blackboard, and some practice questions, and open it up for any other comments or questions that uh, anyone may have. This is we are recording it also just for others to take a look at, or anyone else that wants to go back and see it. It'll be posted later today. Um, okay. Similar format as the first two exams, that is mostly multiple choice questions related to the chapters directly. But all the material builds on uh, on previous chapters. Hopefully, you're feeling more confident as we go further and include more of the nutrients and more of the connections. And yes, making connections. Okay, just look again at our syllabus where we are. We are at week 11, that's chapter 14. And so should be familiar, and should have that syllabus around all the time. And so the end of this week, 10th through the 11th, the exam will be open, similar to the previous two. You choose a time that works, and set away that 100 minutes available for the exam, where you can focus, not being distracted, and using the lockdown browser and Respondus, and just following the instructions through that, and hopefully do well. Most everybody's doing pretty well on exams, also getting through the mind tap exercises and the discussions. Uh, Again, 4 exams. This will be the third. That's 60% of the exams. 30% are the mind tap assignments, and 10% the mostly it's the discussion board comments. This is this week's discussion board, where it asks you to read this short commentary that appeared in Nature Medicine, um, and it's an um, interesting idea. It's not a new idea that food is medicine. In fact, it goes back to the beginning of medicine, that it was kind of stated that yes, our food is medicine, and should be thought about as such. Through the decades, it's maybe not been front and center in regard to our medicine and practices. But now there's initiatives, both in academia and in the medical community, to have this thought put forth again, that hey, food is medicine. It's the material, the most of the stuff that goes into our bodies, and we know there's nutritional and medicinal power to that, to food. And let's think about that. So there's initiatives taking place, and that's what this article. It's a commentary that talks about a bit, and the discussion question is basically for you to reflect and give a comment about how successful you think this initiative will be. It is in action, and there are even clinical control, random controlled studies that are looking at this idea of how well will this work to emphasize food as medicine. Uh, and a cute end of the article says dietary prescription should be on the table. In other words, our medical community, our practitioners should be emphasizing it with those they interact with, the patients and others. The previous discussion question was very interesting. Really, I'm really thrilled to see all these really nice questions that everybody are thinking about. There's just a few of them that I abstracted from the discussions. It shows that we're all curious about our health and our intake of food and how they're related. Food and mood, healthy processed foods, are there such a thing? Is there minimal nutrition that we can abide by that make sure that everybody gets? So these are some of the questions that your peers have been posting. Sugar and kidney stones, and most of these don't have fast, quick answers, easy answers. Otherwise, you wouldn't be wondering them. Superfoods, are there even such a thing? And there are discussions about these. There's most of them that no, there's not uh, uh, an easy answer. And that's what's interesting about nutrition, that we are kind of an individual little trial within a big mass of us trying to understand nutrition, because each of us has slightly different kind of interactions with food. One of the questions, uh, this in the middle there, varied effectiveness of eating patterns, and the gist of the question was, um, why would some eating patterns seem to work well and keep people healthy and balanced, and other people trying that may not be having those kinds of outcomes. So keep those questions in mind, and something you might want to follow up on, and maybe at some point um, do some serious research and write something up or use it in another course, and this kind of thing. So interesting seeing the interaction in the discussion board. Um, a really good point is to think about what's real food, and we should be thinking about this all along, of course, and what's processed foods. In the text, there's a nice example here, and this is with regard to some of our important nutrients, minerals, uh, and the one, as you see there, is one is potassium and one is sodium. So potassium might have been and is commonly a nutrient that a lot of people don't get enough of. That just in the eating pattern, it's low. It's very important. It's an important cation in balance in cells, and it's one that we constantly need to refresh. It's water soluble, of course, comes out in sweat and other bodily functions, even in our, of course, in our uh, um, urine, and it needs to be kept up. And the other one is sodium, that's showed here, these two in food. Uh, Naturally occurring in many foods, potassium is in good amounts. So you look at the top there, the purple milk and some meat and corn and peaches and rolled oats. And then when these same foods are put in processed means, so processed means it might be more shelf stable, it might be more convenient. However, a lot of the potassium is replaced with sodium. And it's uh, due to loss during cooking or preserving, and sodium chloride added for as preservative or even for as a flavor enhancer. So that's um, uh, one way to be thinking about processed foods and how lots of times it decreases the nutritional value of foods, especially for nutrients that lots of times we're um, at um, don't get enough of, in this case, potassium. And when you have the time, many of you do cook yourself, and it is the best way. We know we buy certain ingredients. We maybe have healthy or cultural ways that we prepare foods. This is tofu, and I've been experimenting with tofu for years. Um, uh, Not a complete vegetarian, but we don't eat a whole lot of meat, and tofu is a mainstay. If you look at the nutritional content of tofu, um, there's 77 calories for a decent serving. It's kind of low, and this is fried tofu. It might be with an olive oil or peanut oil. And if we look at the nutritional content, which we all should be aware and kind of curious about, always looking at food labels. On the right, percent of daily value is kind of low in most things. So tofu is satisfies most people. It fills, and it also carries flavor, and along with other ingredients of a dish, could be very healthy on a regular basis. As you can see, it's low carbohydrate. The fat or oil, fat comes from whatever oil is used, and in this case, most of the time we're using plant oil, and it's totally plant-based. Carbohydrates, pretty low. Protein, that's kind of a modest amount of protein, so it's not something that we look for the majority of our protein. Most of us need uh, between 50 and 100 grams of protein a day, so it's kind of low. But it's a replacement for a meat replacement for sure, and kind of seen as healthy eating. Another kind of curious, I've been once in a while I have a Beyond Burger, or try the hamburger beef burger substitute, and this is one of the popular brands. And when we're in New York City, this is we visit this restaurant. It's kind of a neat place. They have a couple of locations in Manhattan. But if you look at the nutritional content of their Beyond Burger, I can see a whole lot of ingredients, and most of these you can recognize, as opposed to some food labels have a lot of chemical compounds and things that may not be familiar with. But most of this is pretty understandable. You don't need to be looking up the chemical makeup of these things. They're mostly natural ingredients, from pea, canola oil, coconut oil, rice protein, starch, and a number of other things. They add some, you can see there's some vitamins are added there. And if we look at another display of the detail, you can see, and we know how to read food labels, and now it's 230 kcals. We compare that to roughly 2,000 kcal a day as an average that's used for food labels. Look at the big thing here is cholesterol is 0. There's no cholesterol in plant-based food. Sodium, kind of modest. That's not a whole lot. 390, 17% of that 2200 milligrams uh, maximum recommended. There's a little bit of fiber that we don't get in just beef or most meat. And protein, 20 grams. That's not bad. And these are some things that they add to make it a little more rounded nutrition wise. We compare that to a regular burger. Their burgers at the burger joint are very, very good. If you like hamburgers, are really top notch. You can see the difference in kcals, uh, more than double. So that's a significant amount of calories of the 2,000 that that's roughly what most of us need. You can look at the fat is very different in the fact that most of the fat is saturated fat. We know that that's not the healthy kind of fat. We should be getting only roughly 10% of our fat as saturated fat, where the others should be unsaturated, polyunsaturated, at least monounsaturated. Cholesterol, so that's a big dose of the dietary cholesterol, about 50% of it. This is in one burger. We're comparing that to the plant-based burger on the right. Sodium, big chunk of the daily sodium there, 30% in one burger. And the rest, not too much else. But here you can see much more protein, about more than double the amount of protein. So, as we know, protein from meat is most of the time more balanced. That means has all the complement of the 11 essential amino acids, where sometimes plant-based that doesn't have the full complement of the amino acids and have to be kind of supplemented with other types of plant protein. So that's a comparison. And hopefully from this course you have the kind of awareness that you can do these tracking type things on various platforms. This is another one called My Food Diary at the US uh, uh, um, USDA website. There's another food tracking database that's very good also. Right now you're using the one in MindTap. So chapter 10, we go on to the vitamins. So again, this section of the course is vitamins and minerals. This is from the that study outline that is in each of our modules. We have these, and I highlight um, I think is the most important aspects of the chapter to be aware of, to make sure it's in your kind of studies, and if you're taking notes or at least reflecting on. So these water solubles are the B vitamins and vitamin C. So there's a handful of B vitamins, and that first they were numbered from 1 to 12, and then some of them at second review were not seen to be a full vitamin. They weren't essential, that the body doesn't necessarily need them for normal operation, normal processes, or they're made by other vitamins so they're not essential. That is, don't need to be taken in on a regular basis. That we don't make enough of them to for our needs. Um, so so I'm not on a question. I'm not going to ask list all the B vitamins, but certainly have an idea of each of them, what's their major function, where they involved in, if we say thiamine or riboflavin or folate. Each of these you should have at least one thing that maybe they're mostly um, uh, has a role in. Vitamins don't necessarily have a single role. Several of them have two or three major roles. Food sources, not as essential, but you probably have a feeling for where these vitamins come from. Some of them discussed, like B12. B12, it's hard to find really great sources of B12 in non-meat, in plant. Um, on the other hand, we do make a certain amount of B12, which is interesting, in our gut. But for B12, uh, either supplementation for those that don't eat meat, or certain kinds of seeds and nuts have some amount of B12. So one instance. Certain of the vitamins, there's distinct deficiency diseases connected with them. The one that should come to mind that's very severe but has been minimized with the right kind of vitamins at the right time, and that's folate with pregnant women. That was responsible for spina bifida, a very serious kind of condition for newborns. But that's a vitamin that is usually taken for a course of pregnancy to avoid any issues like that. Okay. Fat solubles, there's 5 of them, four fat soluble vitamins: A, D, E, and K. And these are similar to um, uh, in their absorption and their transport, similar to lipids. They need a way to be transported, and they don't like to be in the bloodstream, so they're absorbed and transported similar to lipid. Okay, and they're deposited, they go to tissues, or they're stored for a bit of time in the liver. So again, when we think of A, D, E, and K, we should have things come to mind. A, antioxidant. D, we're thinking bones and nails and teeth. And E, we're also thinking antioxidant. A, vitamin A, let's back up a minute. A, we should be thinking, okay, it has a role in proper vision. It has a role in membranes, mucous membranes. It has a role in skin, and what's the other? Reproductive. It has a reproductive health role. So vitamin A has a few really important roles. D, we just mentioned, big with interacts with calcium, bone health, and related. E, alpha tocopherol, that's antioxidant. K, we should think of clotting. It's involved with proper blood clotting. Okay, free radical. The antioxidants involved in quenching or just interacting with free radicals so they don't damage healthy tissue. And water and major minerals. Water, we know, makes up the majority of our weight. It's our blood. It's all our reactions take place in water. Proper water balance, important, and minerals is what keeps, for the most part, the balance of the water in cells and outside of cells in the bloodstream. And the major minerals, well, the minerals in general, minerals really talk about cations and anions. Those are things like potassium and calcium and chloride and sodium, and they're charged. So cations are positively charged substances or particles, and anions are negatively charged particles. And they serve to keep the water balanced. The chemical process involved there is osmosis. It's a few of the chemical processes related terms we should know about. Osmosis is the movement of water from a high concentration of solute to from low to high, rather. Osmosis wants to equilibrate the concentrations on two sides of permeable membranes. And trace minerals, and just called trace because it's in a couple orders of magnitude lower. They're just as important as the major minerals, but just lower quantities. And so a major mineral example would be calcium and sodium, and a trace would be these that we see here: iron, zinc, iodine, etc. Again, each of these have important roles. The major ones we should have in mind a few things that they're involved in. For instance, iron. Iron, of course, is key in hemoglobin transfer of oxygen, in other enzymes. Zinc has involvement in the pancreas and insulin. Iodine, pituitary gland, and the others that are shown there, copper, manganese, fluoride. They often have roles with enzymes, so they're cofactors with making enzymes work properly. And so the other chapter deviates a little bit into another area that we pulled together some things, and that's fitness, physical activity, nutrients, and body adaptation. It's a lot of this we've kind of seen before and have a feel for it. This talks about things of balancing fuel that we talked about in chapters 6 and 7, glucose and fat, generating energy through the glycolysis and um, Krebs cycle to generate ATP, and storage of glycogen in muscles. Some interesting facts there, that we could store up to about 2,000 calories worth of glycogen. So we can extract about 2,000 kcals from the glycogen storage. So that's about a day's worth of calories that could be stored as glycogen. However, we don't use preferentially glucose all the time. It's mixed, just like in a combustion engine, gasoline mixed with oil. Well, our body does that kind of thing. With glucose is the major, just like gasoline, but it also has the oil, and for us it's lipid and fat. And how that the combination of use of glucose and lipid and fat is kind of varies among us as individuals, of how that mix happens is kind of still not understood completely. Let's see, principle of carb loading. Well, that's the idea of glycogen storage. So just like adipose can be fat stored, glycogen can be built up to a certain level. For athletic events, this idea of glycogen storing for endurance event is there. Let's see. So a reminder of this resource is this study it test for each of the chapters that look like this. Really good review material, nicely presented. As I keep mentioning, no longer in the general textbook. This was from earlier versions of the textbook, but you have it here as a nice review for each of the chapters. Overview of the B vitamins. For the most part, they serve as coenzymes. They're small, organic, that means carbon-based, and they don't hang around too long. It's not clear, really, about how long a molecule of thiamine lasts and hangs around. Probably varies among individuals, maybe the amount of water that we take in and excrete. So here's a nice table here differentiating between the water-soluble and the fat-soluble vitamins with regard to their absorption, transport, excretion, etc. And as mentioned, fat-soluble is just like fat-soluble food items. They first enter and absorb through the lymph system, and then just like fat transported with glycoproteins, like if you recall the chylomicron, etc. Okay, and fat solubles, vitamin A, E, D, and K. Really nice summary here. So in addition to looking at these kind of things and studying in that way in our resources, I had this table if you wanted to fill out yourself. It's good to be writing also. It goes through your kind of eyes and brain and writing onto the paper. It's a good if you're in practice of studying like that too. It's a helpful idea. And they have some good questions for us to, highlighted questions on these that could show up on our tests. Also, how is vitamin D unique among the vitamins? Well, for vitamin D, it's involved with many things. For instance, with calcium absorption, with bone formation, and it's the one vitamin that acts as a hormone. That means it's moved to a place and has some kind of initiates some action somewhere else. So with vitamin D, it helps in calcium absorption, it helps in formulating, reforming bone tissue. And what's that question? Keeping minerals available in the blood, vitamin D targets. So those are places acting as a hormone. It goes to these sites: intestines, that's for absorption, kidneys, and for reabsorption, and for bones for bone formation. So acting as a hormone. So vitamin D, where do we get that? We get it in some foods, and also, of course, this is the vitamin that's unique in that we get it from formed in our skin with UV from the sun, and its precursor is cholesterol. From cholesterol, and certain mechanisms at our skin with sunlight synthesize is vitamin D. And it's activated actually going a more complicated process at the kidneys and the liver to make the vitamin D. Okay. So again, these are good study guides, and you've read, you're seeing it a little bit in MindTap, and in the previous lecture talked more in detail about some of these processes. Regulating blood pressure, that's an important mechanism. That's a control. It's a feedback control mechanism that operates with these hormones here, and ending in water and sodium retention or excretion to regulate and actually constrict blood vessels to increase the pressure when it's low, to load pressure, and high blood pressure to get rid of more water. Okay, more questions to review there. Trace minerals. This is what I was talking about. If you wanted to use this as a study guide to be thinking about or fill out yourself, or here's a more formal one that I filled out before. It's just putting a lot of information in one place. There should be vitamins is 1, 2, 3, 5, and 6, and then it jumps to 7, 9, and 12. So those are the B vitamins, water soluble vitamins. Should have in mind again I call it a chief function or role that each of them have. Many of them again are coenzymes. They're part of big systems, big part of the energy generation systems, and deficiencies. A lot of deficiencies of B vitamins are related to just not having the energy to feel normal, to run our formal processes. And so this is from the book, just showing an idea. These are all in the purple are various water-soluble vitamins. All right, so niacin is this one. Riboflavin is the other one right here. So they're dispersed in the energy systems there. Let's see, some of it here is involved in fat metabolism. So it's good. This is back in from chapter 6. It's good to review this. And here's amino acid metabolism. You can see that this is thiamine involved there, and B1 and B6 involved in amino acid metabolism. So here's now some other representative or sample questions. We've seen this question before. The sum of all chemical reactions in living cells is metabolism. Although these words should also know also by now. I mentioned that osmosis is the movement of water across membranes to equilibrate the concentrations on two sides of a semi-permeable membrane, which is not a feature of a vitamin, though vitamins are organic, meaning they're carbon centered. So they could have nitrogen. Thiamine is nitrogen. May be required in large amounts, but that's kind of relative to something, but whatever. And they're okay, the one that operates as a function as a hormone is D. And so this is interesting. You may have picked this up from the reading. The first, actually, the first dose of anything we get as newborns, normal newborns, is vitamin K, because we don't have that ability. We don't have storage. We don't have in utero. We don't get vitamin K. Uh, if if for some reason a newborn needs to clot, if there's clotting needed, they would not have it if they wouldn't have the capability if they're not don't have that first injection of vitamin K. And that's bioavailability. That's not just what's in a food item. It's not just what's taken in, but is absorbed and used by the body. Bioavailability. So most of the weight of the body is water. Iron. So this is the importance of iron, uh, and so all those are, of course, related to iron, whether it's movement of iron through the blood, storage of iron, or but uh, the process of oxygen in red blood cells is hemoglobin. In the muscle, is the myoglobin. As it sounds, this is how it's transported, and this is another form of storage of iron. Okay, FAD. So FAD and NAD, these we try to remember that it's these are involved in energy metabolism in the Krebs cycle, and the FAD is the riboflavin. You don't have to know the structures, but they do redox kind of reactions in the complicated process of making ATP. Which of the following is not among the features of fat-soluble vitamins? Fat-soluble vitamins, so they are absorbed like fat, so they do need the bile. Just like we said, it's lymph through the lymphatic system. They're let's see, not found. They are found in fat and oily parts of the body. So they could be in adipose tissue, they could be in the liver, could be in parts of muscle. Transported permanently to the liver and adipose tissue pose a greater risk of developing toxicity than water soluble. So that's true. This is true. Fat-soluble vitamins could become reactive. They could become oxidized. It could act as free radicals. So it is the answer is C. So they're not permanently transported to liver and adipose. That wouldn't serve the purpose of the vitamins going to where they're needed in lots of parts of the body. The tissue that stores vitamin A, that's liver. So vitamin A, yes, it does have an involvement in vision, and so it is involved with retinal cells in the eye, and it also is involved in the health of intestinal mucosa. And but it's stored in the major storage is in the liver. So the vitamin that's intensely involved in amino acid metabolism. So if you're not sure, you try to think about what's not. This is the strategy and multiple choice question. So riboflavin is involved with energy. Vitamin A we mentioned is vision and mucosa and reproduction. Biotin, you might remember biotin is skin and hair and that sort of thing. So yes, it's B6. B6 and B12 are protein metabolism related, amino acid related, B6 and B12. Person who shuns dairy and spends most of the time indoors would be likely to benefit from supplement of D, okay, because it's important to get the sunlight to generate the vitamin D. There's some foods that are fortified with vitamin D, like milk and orange juice and things. As far as we know, vitamin A does not play a role in which of the processes. So vitamin A notably has those three very important functions, but it's not involved in blood clotting. So that's blood clotting is vitamin K. But these are those are the main features of vitamin A. These roles of vitamin A right there. And the neural tube defect, also known as spina bifida, is the deficiency of folate, pregnant women. So you think too, these are the major deficiencies shown here, the four notable ones. Scurvy is deficiency of vitamin C, beriberi is thiamine, and pellagra is niacin. So pellagra, that's the skin condition, dry skin, severe dry skin. Beriberi is organ cells uh, become decrepit and is dry and wet. Beriberi, but it's related to thiamine deficiency. Vitamins critical to energy, virtue of acetyl-CoA. Okay, involvement in acetyl-CoA, which vitamin? So we said this is protein. This is, in fact, this is the one. So pantothenic acid, not a real popular vitamin, but it's the one that's actually a part of acetyl-CoA. It makes up acetyl-CoA, pantothenic acid. We don't need a whole lot of it, and it's very rare that we're deficient in pantothenic acid. Gatorade. Um, the Gatorade, which is not true about Gatorade, is from my alma mater, University of Florida, the Gators. So all of these are true. It was first developed from the sweat of studying Dr. Cade at the University of Florida, studying the intense sweat from athletes, football team in particular, and named after the Florida Gator. So it's formulated after what's lost in sweat minus the waste products, and to put back and to absorb water rapidly. At first, it just had those balance of electrolytes that are lost, like calcium, sodium, and chloride, and iron, and something else, magnesium. And it tasted horrible, but the football team drank it, and then they started sweetening it to make it more palatable, and then developed into Gatorade, a commercial product. And Gatorade, the brand, was sold from the University of Florida, and sold a couple of times, and started the big business of sport drinks, which is not known to be involved in bone health, and that's vitamin E. So vitamin E is an antioxidant, but these others right here, hydroxyapatite, vitamin D, and fluoride are all important components maintaining healthy bones and teeth. Okay, electrolyte, just a few more. Electrolyte and water balance in the body is maintained by what? And it's osmosis. Okay, so that osmosis will definitely be on the test, a couple of questions. So remember, osmosis is keeping balance of, in our case here, electrolytes by the movement of water. So, for instance, across cells, cell membranes, even in the GI tract, movement of water to establish equal concentrations on two sides of a permeable membrane, semi-permeable. Bioavailability of vitamin in food. So that's a combination of things. It's not just the amount that's in the food, so it's not that one. The amount absorbed and subsequently used by the body. That's the key thing. So that is the answer. It's not the other stuff. It's not escaping the destruction of food processing, although that's important. The number of chemical forms with the same vitamin. So vitamins can be in different forms. For instance, alpha tocopherol, that is the precursor for vitamin E. Beta carotene, you're more familiar, makes two vitamin A's. Okay, again, this is a repeating question. No, maybe not. Function as a hormone, that's vitamin D. K, again, is for clotting, blood clotting. Alpha tocopherol, that's vitamin E. And phyloquinone is what? It's a form of another form. Oh, God, I don't remember. Another form of another vitamin, a precursor. But don't worry about it. Not a property of electrolytes. Uh, they do move water. They are charged. They can carry out electrical. Yes, it is E. They're not fat soluble. Uh, they include fat soluble as well as water. Now they're all water soluble for the electrolytes. And which of the following explains why B deficiency leads to lack of energy? It's because they act as coenzymes in energy metabolism, and we don't produce enough of them. So that makes anything essential if we don't produce enough of them, or at all. Vitamin E is an antioxidant. Antioxidants react and get rid of free radicals, which are dangerous, but we produce free radicals commonly just in our normal metabolism. That's why we need a couple of these vitamins that are antioxidants. A pituitary hormone. What pituitary hormone regulates kidney retention of water? Okay, that's this ADH. ADH, antidiuretic hormone. You might be able to just pull out diuretic. That's stopping the loss of water. So that's for retention of water. ADH. And that's related to control of blood pressure. Okay, and these also from the book, you can look at these. These are kinds of the short answer questions that probably be asked, something like these. These are for the water solubles, critical thinking, and the fat soluble questions. Something like these. I mentioned about the vitamin K in newborns. Three, uh, discuss three associated bone diseases with vitamin D metabolism. So the vitamin D, you might remember the extreme deficiency is rickets. Then you have so vitamin D important for bone health, and with lack of vitamin D and calcium over the long term is kind of we lose rebuilding of bone, and that results in long term softening of bones and that kind of chronic disease. So as always, we think of physiology, we think of the organs, and we think of the specifics uh, around making connections. And so that will end here. Any any last comments or questions?
No.